Hey yo, it's your boy Mr. Gucci here. I'm gonna help you do the constructed response, aka free response questions for the Unit 9 final exam review packet. So, this video is going to encompass questions 7, 8, 9, and 10, as much of that as I can get into the video. It's going to be a lot of stuff, so I think I'm not going to do everything. I'm just going to focus on what I think are some good representative examples here. So I'm going to do from problem 7, I'm going to do, I'm going to do these guys right here. Okay. So for these ones, we have to calculate the molar mass of these compounds. So let's get to it. Here we go. Drawing. So the molar mass is just, you look up the substance's atomic mass on the periodic table, and if it's a compound with many different parts, you add them all together. So 7A is H3PO4, hydrogen phosphate, phosphoric acid, okay? This is made up of 3 hydrogens, so H plus H plus H plus 1 phosphorus, so plus P, plus 4 oxygens. Now, this is a real bother to write down. So what we can do is we can just say this is, instead of H plus H plus H, we can just say this is 3 hydrogens. And in fact, I'm going to do this in a different color so it's not as confusing, all right? But instead of all that stuff, we can say, okay, this is 3 hydrogens plus a single phosphorus plus 4 oxygens. And where do these numbers come from? They come from the periodic table. Let's go. So hydrogen, here it's fine, periodic table. The molar mass of hydrogen is 1.008. So 3 times 1.008, all right, plus the molar mass of phosphorus. Phosphorus right here is molar mass of 30.97. So plus 30.97 plus 4 oxygens. And oxygen, I remember, is 16.00. So the molar mass of H3PO4 is 3 hydrogens plus a phosphorus plus 4 oxygens. I'm going to add that all together. Okay, and I got as a total molar mass 97.99 grams per mole. All right, 97.99 grams per mole. Okay, now 7B asked us to find the molar mass. Oh, no, we're going to skip a B. That's easy. B is easy. We're going to go to C. All right, C is CaCO3 dot 3 H2O. Okay, this is a hydrate, so this is going to be a calcium plus a carbon plus 3 oxygens plus 3 H2Os. All right. This little dot right here means waters are attached. It does not mean multiplication. All right. It is plus. So we're going to go to the periodic table. We are going to look up these molar masses of calcium, carbon, oxygen, and we'll work out water in a bit. All right, so 1 second. Here we go. Periodic table. Calcium, all right, 40.08 plus carbon, which I remember is 12.01, plus oxygen, which we just did above, which I remember is 16.00, plus 3 waters. Now, water is H2O. I've worked it out before. It's 18.02. So you add those all together. Let me pause. I got 154.15 grams per mole. If your numbers are slightly off because of the periodic table values differing slightly, That's okay, guys. You'll have your periodic table to work with on this test, so you'll have access to everything you need. All right, let's do one more. That's kind of tricky. All right, the molar mass of 7D was NH4 2 SO4. So here we go. NH4, but you've got two of them. So you don't have one nitrogen, you've got two nitrogens. Second. You've got two nitrogens. And you don't have four hydrogens, you have 8 hydrogens because it's two of these things. So 2 times 4 is 8, plus a sulfur, plus 4 oxygen. So let's find some of these values. So 2 times nitrogen, nitrogen is 14.01. All right. Plus 8 hydrogens. We did hydrogen before, 1.008. Plus sulfur. Where is sulfur? Sulfur is 32.07. All right. Plus 4 oxygens. Oxygen is still 16. All right. So now I'm going to add these all together. 1 second. I got 132.15 grams per mole. All right, and that right there is problem number 7, A, C, and D. Let's take a look at problem number 8 from the review. All right, so problem 8. Convert the following mole values into grams using molar mass. Okay, so for this one, I'm just going to grab A, B, and C. These ones are relatively straightforward. Let's go for it. So convert moles into grams using the molar mass. All right, so here we go. Now, one thing you'll remember is that if you start with moles, you multiply. All right, so 8A, we want to convert 3.00 moles of tin into grams of tin. So we want to get out of moles into grams. 1 mole of tin is how many grams? Well, let's go to the periodic table. Tin, 118.71. 118.71. So we just multiply 3 moles of tin times 118.71 grams per mole, and we get, for our answer, 356.13 grams of tin. When you're starting with moles, you multiply. All right, let's do another one. These ones aren't so bad. B, all right, we're starting with 0.400 moles of KCl. And we want to figure out how many grams of KCl that is. Well, we want to get out of moles into grams. We have a little bit of work here because KCl is a K plus a Cl. So K is equal to, potassium is 39.10. All right, plus Cl, which is 35.45. So KCl, 39.1 plus 35.45. The molar mass of KCl is 74.55. So yeah, when you want to do these conversion problems, you have to make sure that you get the molar mass. So 0.4 moles of KCl at 74.55 grams per mole, so a little like less than half of a mole. So it's going to be less than half of this. We get 29.82 grams of KCl. All right, great. On to problem 8C. All right, this one is 7.50 moles of SO2. And we want to figure out how many grams of SO2, sulfur dioxide, that is. So again, we're starting with moles, so we're going to multiply 1 mole on the bottom, grams on top, and like above, we got to figure it out. S plus 2 O's. So sulfur is 32.07 plus 2 times 16, 32.07 plus 64.07 grams per mole. So that's how much 1 mole weighs, but we have 7.5 moles. So we're going to multiply them together and get 480 point, fix that, 480.53. Cool. Cool. All right, there we go. So that's problem 8. All right, now on to problem 9. Let me get this page set up. Okay, here we go. So I am going to do problems number 9A and B. I'm going to do those ones, okay? Now, there's a reason why I'm going to do them, and I will show you why in 1 second. Okay, so here we go. So 19, we're starting with grams, or number 9, we're starting with grams and converting into moles. So when we go from grams into moles, we divide by the molar mass. Here we go. So 9A, we have got 15.5 grams of silicon dioxide. All right, silicon dioxide is SiO2. So we want to figure out how many moles of silicon dioxide that is. So we want to get out of grams and into moles. 1 moles, and how many grams is that? Well, we got to do a little bit of math down here. A little bit of math. That's going to be a silicon plus an oxygen plus an oxygen. Silicon is 28.09. 28.09 grams per mole plus 2 oxygens, 2 times 16. And that equals, let's see here. Let's see, 28.09 plus 16 times 2. So that is 60.09 grams. So we only have 15.5 grams of silicon dioxide. We don't even have 1 gram. We don't even have 1 mole of this stuff. 1 mole is 15.5 grams. Or sorry, 1 mole of silicon dioxide is 60.09 grams. And we don't even have that. We only have 15.5 grams. So we're going to have much less than 1 whole mole. So 15.5 divided by 60.09, and that gets us it's black here, 0.258 moles of silicon dioxide. All right, great. Now, B, in which we have 435 grams of KCl. Now, there's a reason why I wanted to do this problem right here, okay? So we're setting it up. We want to figure out from grams how many moles of KCl that is. 1 mole on top. Now, the reason why I chose this because I believe we've already added KCl together somewhere else on this test. Here it is, 74.55 grams. So we don't have to add it again, all right? We can just use the same one. It's going to be the same every time you add it. So That's a shortcut that you'll see sometimes on these tests where we will give you the same substance appearing multiple times. And if you recognize it, then you don't have to do that calculation. You can use the same molar mass. All right, 435 grams of KCl at 74.55 grams per mole. We have got 5.84 moles of KCl. All right, very good. That was 9A and B. Now for the last question in this video, which is number 10. So number 10, convert the following amounts into liters of gas at STP. I am going to do, I know for a fact that a question like this will appear on the final. Oh, man. I'm going to have to do them all. I'm going to have to do them all. I'm going to have to do them all because I like you. All right, here we go. So, 1 mole of gas, change the color on this. 1 mole of gas at STP equals 22.4 liters. All right, 22.4 liters per mole. Doesn't matter the type of gas. If it's at STP, it is 22.4 liters per mole. So these questions could hypothetically be easier. For example, A, if you have 7.6 moles of argon, and we want to figure out how many liters of argon that is, well, we get out of moles and into liters, and we don't even need to consult the periodic table because it's 22.4 liters. So 22.4 times 7.6 gets us 170.24. 170.24. Boom. That's how many liters of argon. Now that's an easy one, all right? Let's kick it up a notch. Let's say instead of being given moles of a gas, you're being given 18.1 grams of O2. And we want to try and figure out how many liters of O2 that is. Now, this is a problem, right? This is a problem for us because this 22.4 liters per mole only works if we're converting with moles, but this is in grams. So the first thing we have to do is get this grams of oxygen into moles of oxygen. So we got to divide, all right? 1 mole of oxygen is equal to how many grams? Well, it's 16 times 2, because it's O2, 16 times 2. So 32 grams. That's the molar mass. So 18.01, or sorry, just 18.1 divided by 32. So that 18.1 grams of oxygen is 0.5656 moles of O2, okay? And we can take this mole value right here and we can then do the simple conversion, all right? 0.5656 moles of O2. We want to figure out how many liters of O2 that is. Well, 1 mole on the bottom, 22.4 liters on top. And we get 12.7 liters of O2. 12.7 liters of O2. So if you're being given grams and asked to find the liters, you can't do it in one step. You have got to do it in 2 steps. You got to get it into moles first. And I'm going to show you one more example, all right? 10C, last question on this little worksheet or in this video right here. All right, 0.963 grams of sulfur dioxide, SO2, And we want to figure out how many liters that is. Well, the problem is we can't go directly from grams to liters. We got to get out of grams and go into moles first. All right, we got to get it into moles. Now, the good thing about SO2 is we already did a problem with SO2 here. SO2, SO2, 64.07 grams. 64.07 grams per mole. So 0.963 divided by 64.07, this is a very small amount, all right? You need 64 grams to have a mole. We don't even have 1 gram, so a very small amount, 0.0150 moles of SO2. So we're going to take that value here, and we're now going to plug it back in, all right? 0.0150 moles of SO2. And we want to figure out how many liters of SO2 that is. Well, 1 mole is equal to 22.4 liters. So times 22.4, and I get 0.337 liters. All right, so again, if you're given moles and told to find liters, you just multiply by 22.4. But if you're given grams and told to find liters, then you got to get out of grams into moles, and then you can multiply by 22.4. And I know for a fact there will be questions like this on the final. So anyways, guys, thank you very much. There's a part 2 video coming up shortly.